Hi there. Today I'm going to be doing a teardown kind of disassembly more of the Hakko FR-802 rework station. This is actually the 220 volt system. I just got it off of eBay and I use it with a power inverter. It's pretty easy. So let's get started. So getting off the cover is where we're going to start. I've already removed a screw here, but I'll just take the rest of them off and let's get started tearing into this thing. And this screw in the corner has a little external tooth lock nut, so I want to make sure we put that back in the right place when we start reassembling it. And once you have the 8 screws off, the cover just slides right off. So with the cover off, you can pretty much tell where everything is and what everything does just from looking at it. I mean, you've got the power connector here, power switch, the air pump here, that's all held on with a zip tie and some glue. Just air hoses, the valve, the flow meter, and then control board, a little transformer down there. I mean, it's really pretty simple once you're inside. So I wasn't really sure where to put my camera. I don't know how other people do this, but mine's just kind of sitting on the table, hovering over everything. So let's start taking this thing apart. I'm gonna disconnect these air hoses to the flow meter. So the flow meter is held on with these two little clips here and here. They're a little bit of a pain to get off. I've actually taken the flow meter off before. They're held on with some thread locker, kind of red goopy crap there. So I took some isopropyl alcohol to it and most of that washed away. But yeah, once you get these off, then it just slides right out. So here's a close-up of that little clip. It's just kind of a little clamp that squeezes around it and holds it tight against the thing. So once those two are out, then the flow meter just slides right out with a little bit of force. So here's the flow meter. Mine's got a little bit of, it's been melted. I didn't do that. That's what happens when you buy equipment used. Thing about this, it's actually got a part number still on it. It says MMF-50 by Dwyer. Dwyer Instruments Incorporated. So now that the flow meter's out, I'm just gonna probably take out the dial. So on this valve part, the air hose is kind of less willing to come off this section here, so I'm just gonna disconnect it from the T-joint. So there's a little set screw in this cap, so I'm gonna have to dig out my Allen wrenches. Find the right size for that. So I think, yeah. So yeah, this set screw is just a 1/16 inch Allen wrench. So that comes off and it's pretty cool. Then I'm gonna get a wrench and take this valve off. So I've loosened this up just using a set of pliers, and so that comes off. And here's the air control little valve thing. So next step, I'm gonna disconnect this air pump, and that's held onto the main board with this clip, and then another clip is zip tied with that. So I'm gonna disconnect that as well. So these two connections get disconnected, and then there's screws that hold on the pump in each corner of the pump. So I'm gonna undo those. After you remove those 4 screws, then the air pump still doesn't come out because you can See under there, there's 4 little standoffs. So on the bottom of the thing, there's these 4 screws. They do take a little bit of force to remove. I'm guessing there's some thread locker in there that keeps everything from vibrating everywhere. And those go pretty deep. You can see there's a little bit of thread locker. I'm keeping my hand underneath the pump in case it all of a sudden breaks free. So after you remove those 4 screws, just can flip it over, and then, but I wouldn't pull on the pump because, lo and behold, it's held on with a ground clip. So undo that ground in the corner. And there's that, has ground loop and the lock washer. Once those are all done, still can't really remove the pump because it's connected to the switch, but I'm just going to clip that zip tie and we'll be there we go. And that bundle of wires comes free, and we have our pump. So previously I had asked a question on EEV blog if using a power inverter, which would boost our 120 volts of voltage here to 240 volts, if that would hurt this pump. And it's actually rated, you can see there, it says 230 to 240 volts, 50 or 60 hertz. So I'm all good for using it with the power inverter. This pump's pretty nice. It's got a label on it. It says AP-45C. Can't really see the C under the zip tie. And here's the cool thing about it. It's mounted with little rubber springs, so that's why the FR-802 is so quiet when it runs, is because the vibration from the pump is absorbed by those. And the output from the pump, it's got this little air flow box at the top just for splitting the air, I'm guessing. And you can see here these standoffs on the bottom that were connected to the bottom of the board. And you're probably thinking, well, why do they have this all isolated and nice and still have these standoffs? Well, these were actually so basically what we have left is the board with all its parts, and there's a little, and over here there's a little, I don't know what it is. It's connected there and it's separate, so it must generate a lot of heat for it to be all the way separated and tied out. We've got this little transformer that brings the mains power down to a voltage that the board can use. So let's get started. I'm just going to undo all these cables first. Got this little brown and blue cable that's attached to the bottommost connector. A little red and black connector here. Pain in the butt to get out. I've got a gray and white connector. There we go. Okay, so once all those are out, that's all our connectors, and all of these go down this tube to the heater handle piece. So I'm not going to worry about those. I've decided to just not take off this air hose just because it's such a pain in the butt to get off, and the handle should be pretty easy to tear down, so I'm just going to go straight on to the transformer. Well, with the transformer, it's connected with the there's a little brown wire that goes to the board, and then there's a black wire that's connected to that goes to one of the switches so it can get power. So when you take it out, you can't really take it all the way out. So I've already unscrewed this, so it just comes out here. There's a set of black and white wires that go straight to mains. So if you want to take the transformer completely out, you gotta desolder some wires, but other than that, it's good. I'm just gonna probably leave it in, but you can see that it's an FR-802 from Oryx. And there's a little grounding clip there that goes towards on the side closer to the power switch. So now we're going to try to get the main board out, and this is going to be pretty fun because there's still bundles of wire everywhere. For this component here that's screwed onto the body, it just has one screw through the heatsink, and this is feels like a piece of cardboard that's just protecting the rest of it from contacting. As far as I can tell, there's 4 screws that hold the board on, and they all have spring clip washers. And then you take that out and you've got the board. So now that we've got the main board out, let's just see what we can dig up. Just looking at the board, you can see that it's fairly well made. I mean, they didn't really cheap out on a whole lot of stuff. I mean, just looking at the board, there's a big isolation gap between where mains is connected and where the board starts. Really components that would have to get a big heatsink are wired out of the board and attached to the chassis. It's got Nishikan capacitors, so good job there, Hakko. There's actually some flux residue on the board near the LED displays, and not sure if you can see it, but there's some white residue here and some flux up here. I mean, that should come off with a quick scrubbing. One of the interesting things about this is that on the board, you can see here it's labeled FR-802, but this little blacked out part, it looks like just Sharpie, says FR-803. You can't there. So it seems that they use the same board for both models of that. They just leave off some of the additional circuitry like the LEDs and switches and stuff. So that's pretty interesting because, I mean, if you got really crazy with it, you might be able to hack your FR-802 into an FR-803 I'm guessing there's a lot of code differences on the chip. So here we've got this component that was attached to the chassis of the FR-802. That is a BCR 8km triac, and it's connected, looks like, to the heater here. It goes down traced heater. Here we've got this M3J48, just based on Google searches. It looks like it's a thyristor manufactured by Toshiba. Here we've got an APT1222, that is an optocouplered triac, and that looks like it's connected down the line to the pump. Here's another one of those APT1222 optocoupler triacs, and that's connected down to the other triac, which is connected to the heater. Here we've got the little optical brake circuit that detects if a card is connected, so the machine knows whether it's allowed to change temperatures and settings or whatnot. Since it's just a brake circuit, it's pretty easily fooled. I mean, you just gotta have a slot in the card for there's a slot in the chassis. So, I just took a little bit of a subway card and I kind of faked my own authorization card with that. Here we've got the brains of the whole thing. I was really surprised at this actually because I've read online that Hakko usually likes to run their products with a custom-made microcontroller or whatever, but this I found really, really easily on the internet. It is an R5F2113 microcontroller made by Renaissance Electronics America. DigiKey just says it's a 16-bit 12 kilobyte flash microcontroller. usual 22 IOs. I was surprised that it's a pretty standard chip. I mean, I can get it for $5 on DigiKey. Well, that covers most of the interesting stuff. There's just, normal additional circuitry, some regulators there, a 74HC series chip, 0.1 microfarad, 275 volt capacitor there. That's pretty high voltage. The little beeper. So turning it over to the other side isn't very interesting either. I mean, you've just got 3 7-segment LEDs, some potentiometers to change whatever, probably contrast and such. And we've just got the 4 switches that it has, up, down, and whatever you need to change the temperature. But that's really it for this side. There's nothing else. I mean, if we had the FR-803, then it'd have a bunch more LEDs, but it doesn't. And we've got some pretty standard components here of what Dave would call a jelly bean component. We've got, some 7808 regulators. We've got a 7805 over here. Okay, we're going to do a quick teardown of the handle. It's just these 3 screws. I've already undone one before my camera died. And once you get those 3 screws undone, then the cover just pries off. It does get a little bit stuck. Oh, jeez. Okay, so once you get the 3 screws off, then it kind of opens up, and you want to make sure that the side with the hot air is on the top when you open it. And so in here you can see that this is basically just a little connector. The heater element's inside the tube. I'm not going to go there. I don't really want to go further into this because it's my only heater, so I don't want to ruin anything, but it's pretty simple. Hakko has some guides. Their user manual for the handle is pretty good, and it shows you how to replace the heater and everything, so that shouldn't be too much of a problem.